Great. Thank you very much. So NVIDIA's actually allowed us to do 2 talks this year, and we had a great presentation yesterday where we discussed what we believe to be a solid roadmap towards solving a lot of the problems related to rendering. And rendering is, of course, at the heart of many of the things that we have to think about when we look at VR. So yesterday I sort of, started by talking about what I see the world looking like in 5 years. And it's pretty much that same first slide, where the same problems or the same aspirations that we have around what we want to have in a rendering stack 5 years from now is basically going to be important for VR. And I think that, the promise of VR more than anything else is absolute perfect photorealism. And, you look at Michael Abrash's discussion about how the human eye can see 16K in a 90-degree field of view. I mean, this is hundreds of times more data and even pixels than any video or any game engine today can render. I agree also that 240 frames a second. These are things that the human eye can see. We've done tests where we've rendered things out at 120, 240, 300, and there's definitely there's definitely a difference. And I think that verisimilitude is a huge aspect of what we want to see with rendering, and especially with VR going forward. Also going to be much more important when AR devices try to mix synthetic content with reality. I mean, it has to look basically perfect. The other important piece is that content needs to be dynamic. I mean, the days of having a separation between a video file and an Unreal Engine game, those things will converge into one thing in 5 years. And the work that we're doing is really designed to bring the quality that we want to go even beyond photos and imagery into the realm of interactivity. And in some ways, VR demands at least one important component of interactivity, which is you need to be able to move your head around and look around, and at the very least, that scene needs to change. And 360 videos and images are just a very crude approximation to that. Certainly holographic content and rendering is just a much harder problem to solve. I mean, we're not talking about rasterizing tricks or just doing something in a 2K frame for a movie. We're talking about really giving somebody the impression that they're on the Star Trek holodeck or in the Matrix. These are the big goals that we have to solve. And I think from a platform perspective, I've thought about this a lot, and we're working on really, as a company, on making this a reality. We think the cloud is going to be where content comes from. It's not going to necessarily be an app or a portal or a store. I mean, these things might be, built on these core components, but we think the future is going to be web-like. It may not be a web browser, but it will be web-like, and that is, fundamentally a hugely important part of the metaverse, which is what we all sort of imagine, sort of an open, holographic ecosystem looking like. And then part of our work is really focused on making these things happen, with hardware that is sort of at the heart of it, and GPUs are very much at the center of that. Obviously, VR demands almost everything that a mobile GPU today can offer, or a PC GPU, and we think that in the future that's going to become even more relevant as the experiences people have on every level, even beyond media and entertainment, are driven by GPUs powering rays that are shooting right into your eyeballs. Last year, we actually presented it at GTC as well, and we had one really just one talk to cover both rendering and our work in VR. But given that we now have the ability to sort of focus in this presentation on just VR, I want to look back at some of the things that we did last year that I'm really proud of. So we announced at GTC last year a tool called OctaneVR that was free, and it was designed to let people basically start playing around with a tool system and a tool chain that could create beautiful imagery and or even deeper experiences. And today, all of that work has led to a category that's actually on Oculus 360 Photos, where you can just view all this amazing content, every single 3D image, somewhere between, let's see, what is it, world and nature. World is all synthetic OTOY content, and that really beautifully represents what we want to do as a company, which is to basically power these platforms, these layers that give years of advancement in the realm of VR and holographic content. We put out our own app. It's also been a great tool for people to sort of play around with exploring new ideas using some of the technology we have, and we're looking at essentially making these things even simpler as we go forward. So part of getting all this content onto the Oculus 360 platform, as well as our own app, as well as even some other apps, like, for example, Virtual Desktop ships with some of these scenes. We basically decided with Oculus, and this is actually John Carmack's idea, to create a contest using OctaneVR as the tool and see what people could come up with over 3 months last year. And it was absolutely mind-blowing. I mean, it really sort of surpassed all of our expectations. We set up a web page. We let people download the tools, and the output was just absolutely stunning. We just got amazing content, hundreds of incredible submissions in this stereo cube map format that we worked out with Oculus and with John. And we also provided a cloud service where these things were rendered, because not everybody has the rendering power to do that. If we were to redo that today, we would probably be able to give you all the tools in a web page, and you would never have to do any artistry on a high-end machine. But the idea with this system was not just to feed things into Oculus 360 photos, but also just to create the ability for you to embed this, these kinds of assets in a web page. And even right from the start, people were linking to the gallery even before it was submitted into the VR versions. And that is something that we think is very powerful: is the ability to create a piece of content that works in a web page, that works in a Twitter feed, but also when you have those those goggles on, it looks real. And I think that that's part of our mission statement. Is we want to provide a tool set that allows you to create and publish holographic content. It doesn't really exist, and I think that there's something very, that isn't quite there when you're talking about pure game engines that rasterize this stuff. It's certainly not photographing things and trying to make something out of it. There's something really special about the way these images on Oculus 360 photos look, and that's because they're synthetically rendered. Even if they're coming from cues from the real world, the fact that we're computationally creating them is a really important part of why they look so good. I actually want to spend about 2 minutes having, sort of going back to the Oculus Connect talk that John Carmack did about some of this work.
The equations for all of these things would be, and Jules at OTOY basically
Can we make it louder?
over a weekend where the test image for those and sent back something that they had rendered with some of their stock content. And they have some amazing content that they can't show publicly because it's from some of their private the media partners that they work with, some just awesome stuff that I wish could be made publicly available. But once it got integrated into their toolkit, then we set up the Render the Metaverse contest to my goal was to try to engage artists, which is, we're talking mostly to programmers. Generally, when I'm up here, I'm talking to the programmers and implementers that are going to work the engineering side of things. But here we were with something that had an artist's tool as the primary interface to it, and I was excited to see what real artists would do. When you say, here's the technology, you're not messing with it all, you're pressing the button that says render to stereoscopic cube maps. What are you going to produce as an artist in this medium that really had never been done before? This panoramic composition is interesting, and quirky stereoscopic panorama is something that, as far as I know, nobody was making significant content like that. So it was interesting to throw this out and just see what people started doing with that. And I judged every single one of the issues. I felt I definitely did not feel really appropriate as an artistic judge for these things, but I went through every one of the entries that kind of met the criteria and came in, which was, there were dozens each month, so it was maybe 150 or so through all of that. And I genuinely was inspired by seeing these things, where I would see these worlds that had beautiful senses of vision and composition, and I felt that it was a frozen slice from the future, where I'm looking around and the quality was so good, I also wanted soundtracks. I'm sitting in these things and I wanted to hear some background music or some voiceover going on, wind blowing, because they felt so real looking at them. And I wanted to walk down that hallway or look under the bridge or do these other steps. And eventually we'll get there.
So that's a good place to stop, because that actually is where we were in September, right? We had done all these amazing images, and we're at the point where we wanted to basically, we felt that we had sort of mastered that peak quality. I mean, frankly, as a still, you can't get better quality on the Gear VR. You have this, neck and head model that gives you a little bit of position tracking or simulated. But all the things that John was pointing out, the things that we wanted to offer where you could really move through these scenes, I mean, that's our work. That's been our work for the last 6 months and for the next 6 months. And by the time that this year ends, we want to provide a tool chain that makes every single piece of content that you can currently see on any app that ingests these renders navigable and allow basically a really simple tool chain for artists, for content creators, to be able to author this and publish this. So Octane's a huge part of that. OctaneVR allowed you to tap into our GPU render. That's why we're here at the GPU conference. And you can create amazing quality scenes. This is one of our engineers that created a scene in Max, 4 minutes of frame. Granted, 4 minutes of frame at 2K is actually going to take a long time when you're talking about rendering these stereo cube maps that are 18K. Later this year, those stereo cube maps will have to be 24K because you're going to have 4K VR phones where the pixels will have to double in terms of its density to be able to support those streams. So when we were looking at the tools chain around VR, we started looking at some of the things that if you'd seen the whole Connect talk that Carmack was talking about, where we can mix certain foveated animated layers with backgrounds. What we ended up doing was we wanted to be able to support entire 18K 120 hertz streams, and we came up with a solution to do that right out of Octane. And to address all the different pieces that John was discussing, I mean, we basically had created a Lua scripting language, and very much like VRScript, we imagined that Orbex files could be a way for something that's more like a WebGL kind of thing to deliver these experiences. What we found is that artists don't like text and they don't like coding. So we're actually starting to build right within Octane very simple widgets and nodes that while you're creating a scene, you can assign surfaces, you can assign hotspots. These don't need to be scripted. You don't need to even learn the equivalent of HTML. These are point-and-click things that we can deliver today in Octane, and we're building an entire set of UI interfaces around Lua script nodes. And the idea is that when you save an image or a render inside of Octane, anything that's in the scene that you've tagged can have a link in it. It basically gets translated and even stored in a PNG metadata tag, even if you save one image. So we're giving users the tools to create shapes and assign different things in the scene, even if there's not an object. That could be used for audio or other layers. Immediately, whenever you have an object in a scene, we store even within one image a bounding box. That means the points of interest or hotspots are essentially spatially connected inside of a render. And all of this will be enabled in our current Gear VR app, which we're also going to be porting to other platforms. But it's also an image format or a media format that other tool chains can ingest. So from our side, as we think about what the future of this platform looks like, we want to be able to allow you to actually not just save an image and put it somewhere, but actually take your entire scene, render it from the cloud, and cross-publish it with certain specific targets. For example, you look at the Steam Workshop environments. We want to be able to allow you to save an Orbex scene. Now, maybe that can be translated through our cloud service into an OBJ file or a PNG stereo cube map. But ultimately, we want to also provide a library, a tool that allows you to see that at the highest quality on every platform. The same thing with avatars. We're also going to be working on web integration as well. And we think social is a huge part of all of this going forward. More so than any one app or platform, social, I think, is a way of discovering this kind of content, and it's going to be a big part of VR going forward. In the short term, we're putting out a new app on the Oculus home platform for the Gear VR that will allow you to stream desktops and browsers inside of layers, even from your own PC. With the release of Octane 3, you'll be able to start exporting meshes with with your imagery, and that allows you to have all sorts of new types of experiences that will run on the Vive and the CV1. And then we're also going to be starting to see tutorials next month along with Octane 3. Today, you can also get some of these pieces on your PC. Installed.otoy.com has a version of Orbex media server and player for the PC. And immediately, you'll be able to use that to bootstrap different services on your own PC that will work with the Gear VR. So one of those will be streaming your desktop. Position tracking with Lighthouse will be working in the Gear VR app. And then we're also working on, may not have Chaperone, but we want to be able to allow users to be able to create their own environments very easily. So this is a tool that we're working on for the Orbex Media Server. You can drop in a Connect, and we basically built a much better version, I think, of Connect Fusion that allows you to scan in your environment, save that, and when you're sharing a stream from your desktop with other users, this environment's part of that. You can also then splat objects on the Gear VR, and it's free. I mean, this is something that we're just dropping into the Orbex System Tray app along with the Gear VR post server, and it's useful on any platform. It's also a very useful tool in general. I mean, it's expensive to get a LiDAR rig and to do this kind of stuff. So, we felt we simplified that significantly. For the kinds of content and environments that you can export out of OctaneVR, the first thing we wanted to enable was for these kinds of environments to support luminous layers. So you can basically recreate Oculus Cinema type of experiences, or what you see in social, where you can have a stream that ingests some sort of external content. It could be a live stream, it could be your desktop. And that's a really important component of the Orbex Media Player and OctaneVR in the next few weeks. And then if you look at and this was one of the scenes that was, the won second, I think first place in the contest last year. And here's a video of that. And it's beautiful. Seeing this in motion versus just the VR experience, you want both of these to be merged together. You want that unified experience where you can move and it looks like this, but this is also 1K. This is not the same amount of pixels as what you need in a Gear VR. And really what we want is you want to be able to move your head with the CV1, the Vive, magically, whatever it is that the device is. And doing that's tricky because they're not really the same thing. One's a video, one's an image, and of course you have, a video game engine wouldn't work this well. So what we've done is we've basically started to work on a special output format for your stereo cube map frames. You can hit a button, render it to the cloud, and instead of getting back a stereo cube map or a video, you can get back something that's much better, which is that every single frame of your stereo cube map is essentially rendered as a holographic light field texture. This is just one chunk of it, but it's really, you render it as a 1 meter cube. And if you're just generating a still, well, you have the ability for a user, when they see that, to move around in that cube. And it's something that is going to be completely transparent. It's not going to be any harder to do this than it was to render those thousands of images that are currently in Oculus 360 photos. And ultimately, even if you download one of those photos, there'll be a tag that'll launch a cloud service that'll bring in that light field volume. And if you create an animation or you create a movie, those things can be animated and they can be relit. There's many more components that make something that immediately solves VR's problems this year work even better. And we're working towards many, many tools in the coming years that allow us to do this really robustly. We have OctaneVR, which we announced yesterday. Even inside of the imaging component of Orbx Media Player, we're going to be adding support for Octane Imager. Does real-time reflections very cheaply on mobile. Non-photorealistic effects become easy. And also, a really important piece of our tool chain is Unreal Engine integration, where you can actually mix ray trace graphics, light field, cached images like what you saw, and even dynamic rasterized content from Unreal, all within the Orbx Media tool chain. I want to skip a little bit ahead because we're short on time and talk about how we're actually bringing in more tools into the ecosystem. So this render, which is actually part of the Oculus Render the Metaverse contest, is a great example of the kinds of work that one artist can do. It's absolutely beautiful, all rendered in Octane, and no photo could quite capture that. The way this was built was really interesting. There's a little bit of photogrammetry in there, and it was done with a lot of hard work based on photo reference. So what we need to do is make those tools simpler, and we have a lot of that technology through our work with LightStage, where we capture the real world, and we imagine that we want to provide a set of services like LightStage, which is for the high end, but for a greater range of artists and consumers, so that they can tap into some of the amazing work that we've been doing for years. Like we won an Academy Award for how we scanned in avatars, literally, actors and more. So we started in a very simple approach with just being able to allow a simple phone to scan in material properties and objects. We already have a huge data set that allows you to sort of recreate metallic surfaces. And last year we also showed something that was more on a macro level, where we can essentially capture an environment with one camera, putting that on a tripod. You send that with the Orbx Media server, and it gives you back basically a light field that's not generated synthetically, but it's pretty close. And as we look at the real hard problems, I mean, people are the hardest thing, right? That we want to bring into these VR environments. That's something that's hard to render. And so we started down the path to making a portable LightStage when we scanned in the president. The work from that is leading towards not just doing a single capture, but doing something that is in motion. And this is really old stuff that we're showing in this video, but the newer pieces that we've done allow you to do super high-res captures in motion. And that was an expensive test that we did a few years back. The new stuff is basically a LightStage and light field camera.
This is Virtual Skylar, brought to you by LightStage.
So that capture was done just a few months ago with a light field plus LightStage camera, $50,000, and you can then bring that asset in motion into Orbx Media Player, and you can relight it. So the idea that you can actually look around an object, relight it, and have that perfect capture done for the cost of a red camera is a huge win, and it's something that we're really proud of. And we're going to work with partners to sort of bring that technology to the forefront. But in the interim, it's a service that we can sort of add to LightStage. So if you want to have people that look absolutely perfect in VR or AR or any other piece of content.
This is Virtual Skylar.
Sorry, it's playing in a loop. I want to close out by just talking about where we see the industry going in the next 2 years. I usually have one of these slides. I mean, it actually is interesting to see, to sort of edit this every time we do a presentation. I think the next big step is going to be what Google does. I mean, obviously, Android is going to become really important for VR, and I think Google's doing all the right moves to make that happen. You look at Project Tango, I'm almost certain, I have no specific knowledge, but I'm almost certain that that will become something that will be baked into Android, and it'll add position tracking on untethered headsets, and that is the future for sure. And of course, you're going to see Oculus probably connect more and more with the Facebook newsfeed. That's a huge important element of how we see the future shaping up. It's obviously why Facebook acquired Oculus. And you have October with the PSVR launch. You already have HoloLens in developers' hands. But I think the real future that I'm looking at a year from now is untethered VR that's really powerful. It's as good as PC VR. That'll happen from more powerful GPUs on mobile devices, but also from just figuring out how to get things like the Vive and the CV1 to work without wires. That'll also help in a significant way. But if I had to pick one device that I think would be the winning form factor, it would be you keep your phone, because everyone has one. Everyone's going to keep buying one. And there are cases where you just want to look at your smartphone. But then you have something like, let's imagine that Apple were to create something like this, where you'd have Beats as a pair of sunglasses that would plug into the Lightning port on your phone. And that, I think, is really interesting, because the glasses are lightweight, they're super high res, but all the computing power is done on your phone, which you're going to have anyway, and it becomes very much like the Walkman model. We know that's what Magic Leap is pretty much aiming for, and I think that really is the future form factor that at least I'm most excited about, because I think that's where you're going to see hundreds of millions of people adopt this very quickly. And last but not least, obviously this market is huge. Things are just blowing up already, in VR. AR and VR, same thing. But again, if you have that pair of glasses that connects to your smartphone as the hub, you can have both in one device. And I think that you're also going to see both of these markets be augmentations of mobile, not a replacement. So again, very, very powerful and interesting next 4 or 5 years ahead of us. I mean, it's going to be an amazing journey. And we're really happy to do our part in making it happen. So thank you very much. Any questions? I'm here for another day.